Okay, this is the worksheet potential energy diagram, and I have my son Colin here to help me. You want to say hi?
Hi.
Okay, so first things first, hopefully you've looked over the notes in the videos maybe and recognize this is a potential energy diagram. So notice the graph starts here, it's a little bit flat line, it goes up to the peak and then it comes down, and then we have these different line segments. So the first question is the above reaction endothermic or exothermic? So before we answer, notice that we start higher potential energy and then we end lower. And we also notice that energy has been given off. So Colin, what's it called when energy is given off?
Endothermic.
Exothermic.
Thermic. I forget. I'm just trying to help.
That's okay. So exo means given off, thermic means heat. Okay, come here. What letter represents the potential energy of the reactant? So remember, of course, this is the reactants and these are the products. So A plus B. A plus B is here. So the potential energy of that is, what letter? Look right here.
B.
B. So going from the bottom to the flat line, A plus B, that is our answer. Okay, next. What letter represents the potential energy of the products? The products is C and D. So this right here is the amount of potential energy for the products. So what is that letter?
F.
Good. What letter represents the heat of the reaction? So the heat of the reaction is the difference between that. So let's just say that's a delta H equals PE, oh my gosh, PE of products. I need to get my other mouse. PE of products minus PE of reactants. Oh my goodness. It's not so. Can you read that?
Not really.
Okay.
I just see kind of like an N and an X and a T.
There shouldn't be an N there at all. Okay. So the difference between those is right here. What's that letter?
D.
Okay. All right, let me scooch it down here. All right. What letter represents the activation energy of the forward reaction? Remember, this is forward. So activation energy is the amount of energy it takes to kickstart the reaction to go from flat line to something. So as you're going this way, Colin, come here. What letter is that?
A.
Good. However, if we were to read it in the reverse, that means we're starting here and we're going here. So how much energy did it take to go from here to the top? What letter is that?
E.
Good. All right, now the activated complex is the top of the roller coaster before you go all the way down. So, Colin, what's that letter?
That is C.
Good.
Just like my name.
Yep. Now, what letter is this reverse reaction, endothermic or exothermic? So if the forward reaction was exo, the reverse starts low and gains. So
Endothermic.
good. Finally, if a catalyst were added, what letter would change? Now, look, we have not talked about catalysts yet, but you have in other classes. Remember, catalysts don't change the results. They just get you there faster. So that means this would be the same and that would be the same. But how could we get there faster? Instead of going all the way up this hill, we kind of go like that. So what letters are going to change?
A.
A is going to change. What else?
C.
C. What else is going to change?
And E.
So A, meaning the activation energy is going to change, the activated complex is going to change, and the activation energy of the reverse is going to change. Hope that helps. Colin, want to say goodbye?
Bye.